Welcome to Lesson 2, Overlay Analysis in GIS. This lecture will cover some basic GIS terminology and give some examples of how overlay analysis can be used to answer various ecological and management questions. One of the many strengths of a GIS is that you can stack several data layers on top of each other for visualization or analysis. For example, if you overlay a map of the habitat of an endangered species and a land stewardship layer, you can find out who is managing the land and where the species exist. The concept of overlay analysis is easy. However, you can get complicated because real-world objects in a GIS can be represented in different features such as points, polygons, lines, and pixels. Each type of overlay requires a unique analysis procedure. For example, point over polygon overlay is different from point over pixel overlay. Vector layers are coordinate-based data structures commonly used to represent map objects. Each object is represented as a list of XY coordinates. Examples of vectors are tree, poles, roads, housing developments, and zoning districts. Throughout this presentation, various examples will be given to show you the types of questions that can be answered using overlays. It's helpful to start to think of your own work and how you might be able to use overlays to answer your own management questions. This map illustrates a point over polygon overlay. The polygons here represent different vegetation types created via aerial photo interpretation. The points are GPS coordinates for vegetation plots, characterizing the vegetation in the area. The GPS points will be used to estimate how accurate the photo-interpreted map is. This is a similar map where the vegetation layer was created via image analysis of a satellite image resulting in a raster dataset, also known as a grid, where colors represent burn severity. Again, the points are GPS locations of ground control points. The color of the point corresponds with the measured burn severity on the ground. Sometimes we want to overlay a polygon layer with other polygon layers or a raster. In the map above, the polygons outlined in black represent fire perimeters, and the raster map represents different cover types. An overlay analysis here can tell you the cover types within the fire perimeters. Two overlay analysis principles will be described here. One, the piercing needle approach, and two, the cookie cutter approach. Both methods involve extracting data from multiple GIS layers at locations of interest. In the piercing needle approach, information from one or more data layers are extracted at one single point, also known as point-to-polygon overlay. For example, you may want to know the habitat type and canopy cover at bird nest locations. In this case, the bird nests are represented by a point layer, and the habitat type, elevation, and canopy cover is represented by individual polygon data layers. The result of such an analysis will be a table that contains the habitat type and canopy cover for each bird nest location in your dataset. The other overlay approach is the cookie cutter approach. This is an example of a polygon-to-polygon overlay analysis. Going back to the bird nest example, rather than extracting data from the exact bird nest location, it might be interesting to analyze the conditions within a 100-meter buffer around the nest. The first step in such an analysis would be to create a 100-meter buffer around the points, or nests. The buffers will be represented in a new polygon layer in GIS. Next, you will need to clip or interest the habitat and canopy cover layers with the buffer layer, and finally, summarize the habitat types and canopy cover classes within the buffers. If the habitat and cover classes are represented by raster data, you would use the raster tools masking, zonal statistics, or combine rather than the vector tools clip and intersect. This map shows the vegetation cover types of Idaho overlaid with the fire start locations for fires larger than 640 acres during the time period of 1986 to 1992. What cover types do you think have the most fire starts? When you estimate the relative abundance of fire in different cover types, you must first consider how much of each cover type there is in the state. If the entire state was covered in sagebrush, then you would expect all fires to start in sagebrush. If half the state was sagebrush and half was forest, you would expect half the fires to start in sagebrush and half in forests, if the fire starts were random. This graph shows data extracted from an overlay analysis of the two layers in the previous map, cover types and fire start locations. First, the black bars show the distribution of vegetative cover types in Idaho. For example, around 14% is in agriculture, 8% in native grasses, 3% in exotic species, and so on. Second, the red bars show the proportion of fires, greater than 640 acres, that started in these cover types. If the red and the black bars are the same height, the number of fires started are in proportion to the land area covered by that vegetation, i.e., random. If the red bars are taller than the black bars, there are more fires than expected started in that cover type, more than random. What cover types have a higher proportion of large fires than you would expect if the distribution was random? If you answered native grasses, exotic grasses, and other shrub and sagebrush, you'd be right. In this graph, the start locations of large fires in Idaho between 1986 and 1992 are compared to aspect. On what aspects do large fires occur more often than would be expected if the distribution was random? If you answered south, southwest, and west, you'd be right on. In the lab, you'll be performing a few different types of overlay analysis for the Selway Bitterroot Wilderness area in Idaho. This map displays the potential vegetation types in the Selway Bitterroot Wilderness. What is a potential vegetation type? A potential vegetation type is a habitat type, i.e., it represents the climax vegetation in an area. The climax vegetation is what would be present on the site if there were no disturbance. How is cover type different from potential vegetation type? The potential vegetation type always represents the climax vegetation, while the cover type is the vegetation cover currently occurring in the area. The cover type on a Douglas fir PVT may be grasses or shrubs a few years after a fire. However, given time, Douglas fir will dominate the site. Zonal statistics is a tool that can be used for overlay analysis in GIS. This tool is part of the Spatial Analyst extension. Zones can be continuous or non-continuous. The zone layer can be raster or vector, but the value layer must be a raster. Statistics that are calculated using this tool include mean, median, standard deviation, min, max, variety, majority, and range. Selected statistics can then be charted. The zone layer in this example is the land use type, while the value layer is the elevation layer. The output table tallies the land use types in each elevation zone. In this example, the zone layer is forest stands, while the value layer is the elevation layer. The output table will show the mean, max, min, etc. elevation within each forest stand. Another useful overlay analysis tool is the tabulate areas in the Spatial Analyst tools. You can create a cross-tabulation based on two data layers. Pause this presentation and take a moment to look at the slide and understand where the values in the table are coming from and different scenarios this feature might be useful for. Let's say you'd like to know how much of each land cover type there is in the watersheds within a study area. You must input the two data layers, watersheds and land cover. In this case, you must also tell the tool what field in the attribute table you would want to tabulate. You can now move on to Lab 2, where you'll practice the many features discussed in this lesson. Future labs will use the skills discussed in Lab 2, so make sure to pay attention and think about the possibility of other applications as you complete each step of the exercise. There are many varied steps in this exercise, so make sure to leave plenty of time to do it. The demo has many tips for working in ARC and even includes some challenges that you might face when working with ARC. In order to fully absorb the processes that are going to be performed, it's recommended that you pause the demo and refer to this presentation or to additional information on the web. Don't worry, most labs will not be so process-based. This is needed to build the foundation of skills for the other, more objective-based labs.